Types of machine learning. Machine learning comes in different forms, each with its own goals and methods. Understanding the main types of machine learning is essential because it helps you choose the right approach for solving particular problem. In this section we will discuss the three primary types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. First one is supervised learning. Supervised learning is the most common and widely used type of machine learning. In supervised learning, the algorithm learns from the labeled data, which means each example in dataset has an input and known output. How it works: you provide the model with examples that include both input features and the correct answers, that is labels. The model analyzes these examples and learns the relationship between the inputs and outputs. Once trained, the model can predict outputs for new unseen data. Examples: email classification, determining whether an email is spam or not based on the labeled examples. Image recognition, classifying images into the categories such as identifying pictures of cats or dogs. House price prediction, predicting the price of a house based on the features like size, location, and number of bedrooms. Supervised learning tasks are usually divided into two main categories: classification, predicting a discrete label such as spam or not spam; regression, predicting a continuous value such as house price. Supervised learning is powerful because it allows models to make accurate predictions, but it requires labeled data, which can sometimes be expensive or time consuming to gather. Unsupervised learning. Unsupervised learning deals with the unlabeled data. Here, the algorithm tries to discover patterns or structures in the data without any explicit guidance on what the output should be. How it works: the model looks for similarities, groupings, or structure in the data. It tries to identify hidden relationship or reduces the complexity of the data. Examples: clustering, grouping customers into segments based on purchasing behavior; dimensionality reduction, simplifying data by reducing the number of the features while preserving important information; as in principal component analysis (PCA), anomaly detection, identifying unusual patterns that differ significantly from the majority of data, useful in fraud detection. Unsupervised learning is useful when you don't have labeled data or when you want to explore and understand the underlying structure of dataset. Reinforcement learning. Reinforcement learning is different type of machine learning inspired by how humans and animals learn from experience. Instead of learning from labeled examples, an agent learns by interacting with an environment, making decisions, and receiving feedback in the form of rewards or penalties. How it works: an agent observes the current state of the environment. It takes an action based on its current knowledge. The environment responds by changing states and providing a reward or penalty. Over time, the agent learns to choose actions that maximize its cumulative reward. Examples: game playing, teaching AI to play chess, Go, or video games, where the agent learns strategies to win. Robotics, enabling robots to learn how to walk, pick up objects, or navigate obstacles. Recommendation systems, dynamically adjusting recommendations based on user interactions to increase engagement. Reinforcement learning is powerful for situations where actions influence future outcomes and long term strategies are needed. However, it often requires significant computational resources and can be challenging to implement for complex environments. Choosing the right type of learning. Supervised learning is ideal when you have the labeled data and clear prediction goal. Unsupervised learning is helpful when you want to explore patterns or structure in unlabeled data. Reinforcement learning is the best choice when decisions need to be made through trial and error with the feedback guiding the learning process. Understanding these three types of machine learning gives you a strong foundation for exploring how different algorithms work and when to use each approach. In the next video, we will dive deeper into the most important algorithms and see how to implement them in real projects. Let's continue building your knowledge of machine learning.